Good morning. Welcome to the Batch Java Overview webinar. My name is Gregg Lippa. I've been with Themis Education for about 8 years now. As you can see on your screen, my email address at Themis is up there, as well as our web address, and the webinars page on themisinc.com, where you can retrieve a copy of the slides for this webinar. Hopefully now, we were just getting them up there, so hopefully they're out there now. You can also follow us at Twitter using @ThemisTraining. Well, let's get started. My first slide here. There we go. Tells us what the webinar is about, and if you start at the bottom, it says we have very little time for questions, so use my email for questions. There is a way to ask questions through the GoToWebinar tool, but we'll be very pressed for time, so prefer to answer those after the webinar ends. If you have a more pressing question, we'll be monitoring those, and you know, if you can't hear or something, you can let us know. So, got a lot to talk about. What are these batch applications and when should you use them? How do you create them? How do you deploy them? And if you're a Java developer, you either use Eclipse or some version of it like RAD from IBM. So we'll see how that plays a role. You get to use the Eclipse environment to do this development. And Ant, which you may or may not have heard of, which is a scripting tool that allows you to compile and deploy and do lots of other things that relate to running Java batch programs. JCL comes into play most typically, but so does the UNIX side of the house, and we'll have to talk a little bit about that if you haven't dealt with it before. IBM provides 3 tools or programs, BPXBATCH, BPXBATCH, and JZOS, to help you to use JCL to run your batch applications, which would then allow you to access regular mainframe files, sequential, PDS, and VSAM type files. We'll look very briefly at logging and console communication. Most of you are aware, if you're a COBOL programmer, that you've got copybooks. There is a tool available from IBM to take those copybooks and create Java classes to support the record structures that the copybooks define. We'll take a brief look at remote debugging. We'll be getting close to the end here. ZIIP is a kind of processor that can help reduce costs, and batch applications can take advantage of that. So a lot of ground to cover. First of all, when do you need them? What are they? A batch application is a standalone application with a main method, like an entry point in COBOL. It has its own JVM, that's Java Virtual Machine. So you're not using WAS or any other Java EE server. You may use Java Native Interface. It gives you a way to talk to a COBOL program. And it's kind of complicated. We've got a brief mention of it at the end of this. But it does need to be triggered, and you can do that right in UNIX, but of course we're used to having JCL to take care of this kind of need running batch jobs, so we'll show you how to do that as well. With a batch application, you don't have someone sitting out at a terminal waiting for a response in a second or two, so we have large workloads, thousands, millions of tasks being repeated to process files and use databases and so on. So we have a potential for some efficiency using batch techniques, and we also have the workload management WLM type capabilities that are supported on the ZIIP platform. Now, legacy systems that might get converted to Java batch are discussed on this slide. And you notice the second bullet, maintenance, modernization, and replacement are the approaches we take with those. We maintain them, as you know, for many years, maybe modernize them and bring them up to date so they have maybe a web front end, and ultimately possibly replace them, and that's where the Java batch is most likely to come in. At some point, maintaining these applications becomes difficult, costly, or unacceptable for other reasons, maybe incompatible with other applications or other environments. One approach is to provide a wrapper, a new interface. So maybe you've got a CICS application, you want it to look like a web application. There is an approach called screen scraping that would allow you to keep the CICS application and capture its information going in and out and use a web front end to do that. It's a little bit less risky than replacing the entire COBOL program that underlies it, but not particularly maintainable. In the replacement phase, we replace the legacy system or part of it with Java code instead. So more risk here. You know, these legacy systems have been running for years and they've been tested and proven, and we're certainly not going to toss them away lightly, but at a certain point this becomes a solution that is at least worth considering. Why would you want to replace the legacy system with Java? Well, we've got 4 points here. The availability of skills. There are fewer and fewer COBOL developers as we age and retire, and more Java developers coming out of school. We also have tools, many tools in the Java environment, including development tools like Eclipse and many frameworks and libraries to support that. Number 2, integration over the network. We have the Eclipse-based IDEs, that's integrated development environments, that have been used for many years and are very cost-effective and productive for producing and developing applications. And we've got in Java a wide range of application programming interfaces to support databases with JDBC, message queuing like WebSphere MQ with JMS, XML parsing, which of course you might be doing in COBOL already, and web services, which are increasingly important in most organizations. As far as performance, you've got capabilities in Java to process large volumes of data more efficiently than more of a one-by-one approach. And we'll talk a little bit about how the ZIIP processors and just-in-time compilers come into play there. Plus, you have the portability. If you decide to move these applications, maybe they're not using regular ZIIP files, just databases, you might ultimately move them to another platform like a UNIX server, and Java supports that. So why Java? Well, some of this we've talked a little bit about. You've got functionality and libraries that are available, including not only utility libraries, but even class libraries that are supporting other Java applications today. Again, you've got XML APIs, SAX and DOM are mentioned there. We won't be talking about those. You may have online program logic that you can leverage and make use of for these more complex workloads and take advantage of the reliability and manageability that the mainframe has to offer. You may be able to improve quality of service and consolidate servers. Again, having the skill sets for the future with Java developers, more so than with COBOL or even assembler. And you've got the powerful IDE, very valuable addition to the developer's tool set. And finally, the ZIIP processor, which can provide significant cost savings. Won't say a lot about that. You can look it up. We do have a short section on it and how it is basically aimed at Java to be able to compete with the lower cost platforms that IBM is up against. When would you use it? Big jobs, and you can, of course, access, in addition to databases, also mainframe files, including VSAM, sequential, and PDS. You can do messaging in and out. We won't have much to say about that, but Java, of course, supports it at WebSphere MQ. You could produce reports, And you could also be up against applications from other vendors that need to be supported or maintained and enhanced. In batch Java, you can do all the normal things that Java does: access databases, call stored procedures, use any kind of mainframe file, talk to CICS using Java connector architecture, go to across the network to do things like accessing web services, and even integrate with other programming languages. Notably that would probably be COBOL or who knows, assembler, C++, but mostly COBOL. Okay, so how do you put this together? How do you build and deploy a Java batch application? Of course, we need tools, and we have tools with Eclipse. We have tools for building, and as far as compiling, deploying, moving them over to the mainframe, Eclipse supports a tool called Ant, which is a scripting language that allows you to define what are called targets and tasks that will automate this process. And we've got some examples of Ant code. It's written in XML. What has to happen is your Java classes have to be written and compiled, packaged into jar files, and then deployed to the mainframe, making use of something called UNIX System Services, which is part of the ZIOS platform. So File Transfer Protocol, FTP, is used to bring all the necessary files up to the mainframe, including the JCL, which can be developed and copied from Eclipse, Unix shell scripts, and many other types of files. In terms of automating this, Ant is crucial to that. Once you have the application up there and ready to run and start debugging, Eclipse supports remote debugging, and we'll talk a little bit about how that happens as well. Of course, in our class, we would have lab exercises that allow you to try that out. So using Ant, what we would be doing, I see some notes about being able to hear. Hopefully it's coming across for most of you. It looks good on my end. Using Ant, we can do the compile and packaging. We package our class files that have been compiled into jar files and upload those using FTP to the Unix side, which is where Java runs. Also, the JCL, which can be managed on your workstation, gets uploaded, and then the job is submitted using JZOS or another launcher, which we'll talk about. The output then, the way the Ant script that we use is written, the JES output is then retrieved back via FTP to Eclipse, where it can be viewed in Eclipse. So while everything happens on the mainframe, the ability to interact with it can be managed in Eclipse. You may have a mainframe session going, and that's fine, but you can do this through the workstation, including the debugging. So Apache is an open source organization. Ant is one of dozens, probably hundreds of tools that it supports. And an Ant build file, again, is an XML file containing targets and tasks. I'll show you an example of that in a minute. And Eclipse and RAD support Ant with its own perspective and capabilities. So Ant is able to work on files that are either in your Eclipse RAD workspace or elsewhere on your file system. And it has an output, a console view for viewing the output. So with a few clicks using the Ant editor, you're able to automate a whole series of tasks to, again, build, deploy, and execute your application. Ant, like many things, makes use of properties files. We have a little example of one. A properties file is simply a centralized place to customize properties, which are name value pairs, which you see on the bottom half of the slide, where the left-hand side is the property name and the right-hand side is the value that can then be plugged into your Ant scripts. You can see towards the bottom how those properties are accessed using symbolic dollar brace syntax. You see ZIOS FTP user ID defined on line 2 and used in a couple of places towards the bottom. Now these and many other properties would be defined, and in an Ant script, where you see an example on slide 17, we have targets. The one you see on slide 17 is compile, and it makes a directory called bin and then executes a task called javac, which is the compiler, which takes everything from a src source folder and compiles it and places the resulting class files into a bin folder. And the other 4 steps are on slide 18, where the jar is built and deployed, and then JCL, which also resides on the workstation, is deployed, and ultimately the last target submits with the Java task to actually run the script. This is a very stripped down, simplified introduction to what an Ant script looks like. And then you can actually use the Eclipse environment to run your Ant build. You're likely to have a target called all that depends on a whole set of other targets. Let me back up to slide 18. You can see on the second target, deploy jar depends equal build jar. So it depends on build jar happening, and if it runs, it will make sure that it runs build jar first. So an all task, an all task like we've mentioned here would depend on a whole series of other targets that need to run. The Eclipse console shows the output from Ant itself, as well as the JES output that's produced by your Java batch job. Now again, these are the 3 tools that are provided by IBM to run JCL that uses the UNIX system services to run your batch job. You can see here that there is a UNIX environment under ZIOS. It has UNIX system services and UNIX application services that allow developers to interact with that environment. On the bottom, we see a component that relates to the SDK. See a question about Maven. Yes, Ant is very similar to Maven. What you're seeing on the bottom is a environment definition of the properties that are required, the environment that's required for Java to run. In other words, where is Java? This is just some sample code that shows where Java 7 would be located, and those would be set in order for the UNIX services to be able to run your Java program. So in your runtime environment, you would have, of course, your compiled Java in a jar file, your JCL scripts that have been uploaded, and your JCL run, which would require an increased region size due to the many system resources that are required. Now we can execute, and we'll take a brief look at the first 2 and focus on JZOS as an execution approach. And this would allow us with the JCL to integrate legacy applications with the Java batch applications in the typical ways that you're used to. So by using JCL, we have Java code running like all the other regular batch work with job scheduling, support, security, And we have the ability to organize the job flow, so the Java program can be one of several steps in a JCL job execution. The job execute, I'm just looking at some of the questions here. Does Eclipse need any plugin to execute the app? No. It needs some libraries that we would point you to in a class and talk about in much more detail in a regular class. You have the ability to use WLM, Workload Manager, to bring output back from the spool and handle it on the Eclipse side as well. So BPXBATCH is the oldest and least capable of these approaches to do that. It uses a variety of DD cards that allow you to run your Java program either from a shell script or as an executable. And in any case, you need this STDENV, the standard environment DD card, to identify where your environment variables are. I'll show you a brief look at how that file looks. There's an inline version in the top box that shows a path and a Java home, but there'll be much more in that file that is referenced in the env.profile in the other two boxes below. So here's BPXBATCH. You see that on the run line that's highlighted, being executed and running a shell script where Java is being used to execute something called my program using a particular class path. So I don't have time to get into all the details of how all this works. Can we run a mainframe job in a Java environment? No, that's a pretty big question. Not a typical approach. So again, what you're seeing on slide 25 is how we run the program, and then in the bottom half, copy the output. One of the limitations of BPXBATCH, one of the big ones, is its inability to access ZIIP files. So we're actually sending the output to a file under the UNIX file system and then copying it in the second step over to some sysouts on the mainframe side. BPXBATSL helps to get around these limitations of what kind of files you can access, and the DD cards. You're limited with BPXBATCH. You are running in a separate address space and the DD cards are not visible. BPXBATSL gets around that by running in a separate address space and making those DD cards available. We don't have a code example for that, but similar to BPXBATCH. Again, JZOS is the preferred, more modern approach. Full support for DD cards, ability to direct your output to standard MVS data sets, and use SDSF to view your job output and integrate your Java with other job steps as well. What we have over the next several slides are some examples that show some JCL. Job has several steps. There's a rex exec that generates some records and a temporary data set rex out. Then there's a sort step, and the sort out data is then input into Java, which updates a VSAM file. So just a brief look at the whole picture, including number 2, the shell script that would support this approach, and the Java program itself. Again, lots of detail here that we'll just be glossing right over. You have the slides, and of course you can get the full picture from our regular class. So here in the first step, a rex exec is being executed, and in the second step, it's being sorted. You see on the bottom there, sort data is being created and then passed to the next step, which is a Java program called process records. And it's using the DD card that points to the temporary sort data data set. Notice again, 3 lines down, the standard environment is set there, and that's shown a little bit on the next slide. On the last few steps, just some cleanup happening through IDCAMs and IEBGener. Here is a look at the shell script that configures the environment. What you notice generally is that the top half relates to system level. You've got Java home and library path that relates to it. And the bottom half relates to the application itself, the class path that includes not only the system files and libraries, but also the Java components that are going to be required to support the application. And finally, on the last couple of pages, we see a little bit of Java code. We see a little bit more in a few minutes, but the highlighted sections here that you see are ZFile. ZFile is part of the library you see imported there on the top line, COM-IBM JZOS, includes the ZFile class, which allows you to support all kinds of different files in the file system. You see how the ZFile constructor is being called and referring to a DD cards in data and out data with some other parameters that are relatively easy to understand if you're familiar with VSAM. And the bottom 6 or 8 lines shows a loop that basically reads the input file into a buffer and then ultimately writes that buffer out to the output file. And slide 34 is really just the completion of that code. You'll notice files being closed. You'll notice the system exit method being called and providing a return code that can be queried to see about the success or otherwise of the application. Just 2 quick slides, one on console communication, one on logging. No sample code here based on our time constraints, but the write to operator macro is supported through JZOS components, MVS console. Does the return code feed the JES condition code? That's a good question. I believe it does. Using the MVS console and some other pieces of the JZOS library, like the WTO constants, you have the ability to interact with SDSF and the console. And also a very brief mention here of logging. Log4j is one popular open source framework that is used for logging, one of several. There's a link at the bottom for more information about that, but certainly your Java applications can make use of Log4j. Yes, in terms of the JZOS question, it is ZIIP eligible. In terms of how do you configure these things, that's way too long a question. Yeah, we have about 15 minutes left, so. And I'm about halfway through my slides, more than that. So accessing MVS data sets, again, please contact me at my email address, glippa@themussync.com, if you want to continue these discussions or ask other questions. Does this require Java code knowledge? Absolutely. It's all about Java. In terms of using MVS data sets, you of course have the ability to access databases. There's no difference there the way Java does that in any other environment as it does in the batch environment. So that is not anything we're going to talk about today. But for file access, especially MVS data sets where most of our file access needs to occur, John will put my email address up there. It's also on the slides on the first slide, glippa@themusinc.com. So JZOS gives you a way and a library to access these data sets. It actually leverages some existing code that IBM has had out there in using the C++ language and provides thin wrappers around that code to give you the same kinds of capabilities to access sequential and partitioned data sets as well as VSAM files, and we'll take a look particularly at the VSAM side in a minute. Here we have some really extensive code, sample code that you can take a look at. There's a program called member copy, and what it does is it takes as input a PDS, and it goes through using JZOS library capabilities. It goes through the PDS and creates a list of members that need to be copied into a second PDS. You see in that third major bullet, PDS directory and PDS directory member info are the ways that we do that, as well as the typical Java approaches that make use of buffered readers and buffered writers to run that code, to copy the actual contents of those members from one PDS member to the other. So there's too much code here. It's just on 2 pages. There's too much code to walk through everything that's happening. If you know some Java, what you're seeing right at the top there in the try block, copy members, member list, arg0, tells you that the name of the file is coming in through a command line argument. Member list is being called, that's just below the bottom half of the page, to create a list, an array list of all the members. And the way it works is it creates an input member followed by an output member name. And then copy members does the actual work. So the bottom of this page is going through the PDS itself, the PDS directory, and iterating through that one and determining fully qualified input name, including the PDS name and the member name, followed by the fully qualified output PDS member name. And then on slide 43, you notice the Z file and file factory are being used to do the actual work. We're creating a buffered reader and a buffered writer, and then ultimately in the while loop, reading from the input and writing to the output line by line and putting in line feed on the output after each one and printing out the final result. Whoops. A brief mention on slide 44 of another program that's provided by IBM that supports dynamic allocation of data sets. And long story short, this would allow you to use a DISP of shared instead of old to allow you to access files in such a way that they're still available to others. Now, working with VSAM files, we have a brief look at what VSAM files are. There's 4 types: key sequence, entry sequence, relative, and linear. Relative, record, and linear, all except the linear data sets that are used to support DB2 are available to be accessed through JZOS. In terms of VSAM terminology, we've got logical records that include a data and a key. In many cases, a cluster that includes a data and index component, and a mention of ID cams that's used to define your VSAM clusters and that has to be done outside. JZOS doesn't support allocation through IDCAM, so that would be a separate task or step in a job. There's a good bit of detail here, and much more in the full class about accessing and manipulating VSAM data sets. You have the capability to add, update, and delete records, as well as, of course, reading them and even getting information from them. So in order to read a record from a data set, Z file first is used to gain access to the data set, then to locate a record using some kind of location strategy like matching on a key, and then once it's located, ultimately able to read the record into a buffer. RecBuff would be a byte array that would be filled with the data from the VSAM record. The read method would then return how many bytes were read. Reading records has to be done prior to updating or deleting them. So here we have a two-page example. Again, a lot of detail, but the key is that we're using Z file. On the bottom third of the slide, you see 3 writes happening, and then a locate and a read. The locate is matching on the key to record 1, which is basically the first 10 bytes of what you see, about 6 lines from the top. The letter A 10 times is the key in this example. And so that's being used to locate and then read the record. And in the second page, we have an example of an update. We've positioned to that record, so now we're updating it. Below that, locating another record, printing it out, and then updating it. And in the final example, reading just a portion of the record rather than the whole thing, just the first 10 bytes, and using those 10 bytes to locate and ultimately delete the record. So you see examples of all 4 of the CRUD capabilities, create, read, update, delete, applied to a VSAM file in this snippet of code. Our next topic is creating Java record classes. This deals with COBOL copybooks, where we're so accustomed to using those for a standard COBOL program. Those copybooks can be used as input, and there's Ant tasks that are provided by IBM and us in the course to support this capability of using a COBOL copybook to create a Java class that supports that type of data and that record structure. It's a bit messy because of a couple things. The potential character set differences and the way that numeric data is stored on the mainframe in packed decimal format. There are some samples at IBM that shows that, well, you could do this yourself, but it would be very difficult. So the provided tool is the record class generator that you see defined there inside of its package definition. And there are steps that make use of the A data output from the compiler to generate a Java class that corresponds to that copybook. And again, there's Ant tasks that support this. I don't think we don't show any examples of that in this short webinar, but we certainly get into it in the class. Once you have that class that's been defined, you can modify it. This example shows building a timestamp from the date and time information that is supplied as part of the copybook. Just a few other topics in our remaining minutes. Remote debugging is supported in Eclipse, and this is going to be important if you need to run the application on ZOS. Either you're accessing ZOS data sets, sequential or VSAM files, or you're having a problem that only occurs when you run it on the ZOS side. The Eclipse Java debugger supports remote debugging from the workstation. And what you need to do is take the usual steps, build and deploy the program, and then start the application, which is running on the ZOS side under UNIX System Services, specifying appropriate arguments that you want to run it in debug mode. Now on your workstation in Eclipse, you begin a debug session, which includes specifying the address and port of the machine where ZOS is running. And that gives you the ability to use the standard debugging techniques in their entirety to set breakpoints and step through the program and view your variables and arguments and so on. Those capabilities on slide 57, be able to watch and inspect variables, even change them, add breakpoints. Any system out print line, the equivalent of a COBOL display statement, will not appear in the Eclipse console since it's not running on the workstation. You would need to see those on the mainframe side, or wait till it's done and then they'll be potentially downloaded to your Eclipse workstation. If you're not accessing any ZOS files or having issues that are related to ZOS, you could also debug locally. Maybe you're just accessing DB2 or WebSphere MQ. That could also be used. That could simplify things if you just debug locally. All right, we got just a few minutes remaining. Mention of the ZIIP processor, IBM's Z integrated information processor that they've put out there to help their clients to lower costs and provide economical Java execution. Again, they're competing against lots of other Java execution environments. ZIIP processors can only assist your general purpose central processors. But if you do have them installed and configured, there is no need to do any Java code modification to get them to be used, and they can reduce your costs potentially quite a bit. ZIIP used to be called ZAP, can be used to support a variety of operations, including, as you can see there, the JZOS library and JDBC drivers, particularly type 4 drivers. The amount of potential for these can vary. IBM's done some research on this that shows there is a great deal of potential for reducing costs with the ZIIP processor. If your Java code is making use of a lot of native code written in C, for instance, the ZIIP is not aimed to support that. But if you've got a purely Java application, you've got a very high potential for ZIIP utilization, and that can range from 0 all the way up to close to 100%. Typically, you get some benefit. So this gives you further incentive to consider using Java batch applications if cost reduction is a factor. JZOS has complete support for these ZIIP processors. DB2 drivers, again, type 4 drivers written purely in Java, also give you the greatest potential for ZIIP cost savings. Lastly, JNI is not something we're going to spend a whole lot of time on, other than to say that it is supported. It is designed to combine with C and C++ code, but there is an ability to combine Java with COBOL code. You just have to go through the C and C++ code to get there. So it's a little bit messy, But once you've got a template in place, it is doable. We don't have code examples for this. They're way outside of our scope, but it does give you the capability to integrate Java with COBOL and have your Java code call a COBOL, perhaps utility function. And that means that you don't have to rewrite the entire application into Java. You could leave some of it in COBOL and make these connections. Big disadvantage if the JNI is not fully debugged and crashes, you could have some pretty severe implications on your system. Again, calling COBOL from Java involves a C++ layer in between, and we're not going to be discussing that. So here's a link to the our JA 1080 class that covers this topic in detail. So please take a look at that. There's also a link to the Java category where we have a full set of Java classes that support all of the Java frameworks and Java best practices and design listed there. Looks like I went about 1 minute over. That's not bad for as much ground as we covered. Again, let me put the first slide up. This has my email address as well as our company address, themusinc.com, and then /webinars, where you should be able to get a copy of the presentation slides, and follow us on Twitter at Themis Training. This has been Gregg Lippa providing a Java Batch webinar. Hope to see you soon in one of our classes. Thanks for coming. Have a great day.